right, so example 2 on finding limits graphically. All right, so here I've got another graph. So here's the graph that's in the guided notes. Example 2, so this is example 2 graph. And so there's a few different things. There's an asymptotic behavior and some other things going on, open points and things like that. All right, so there's my graph. And so we're going to find the following limits. All right, so the first limit is looking at -5. And see, there's no plus and minus there. And so I have to look at both sides of -5. So as x approaches -5 on both sides, meaning from the left and the right, is the function approaching the same thing? If it's approaching the same thing, what is that same thing it's approaching? All right, so -5 is what we're looking at. And so -5 is here. All right, so my -5. And if you'll notice, -5, there's asymptotic behavior here, right? This means this is shooting up on both sides of my -5. And so there would have been an asymptote here at -5. And so from the left, it's shooting up to infinity, and from the right, it's shooting up to infinity. And so there are two acceptable answers for this. You can either say, so on both sides, it's shooting, since it's shooting up to an infinity, you can't ever really get to an infinity. All right, but what you can do is you can approach it. And so we'd actually accept two answers for this. You can either write does not exist because it's approaching an infinity, or since it's approaching the same infinity on both sides, and we do this more in the other calc class, but it would be appropriate to answer this as well if you were taking a test or a quiz. But you could also say positive infinity, because that is what it's doing. As x approaches -5, the function's growing indefinitely. The closer I get to -5 from both sides, it's growing indefinitely and getting bigger and bigger and bigger. And so either one of those answers would be acceptable. Does not exist because it's an infinite, or since both sides are approaching infinity, we'd accept infinity as an answer as well. All right, next one, -4. So again, general limit, as x approaches -4 on both sides, what is the function doing on both sides? All right, so -4. So -4 is right here next to -5. And so there is it's a sharp change. It was coming down and it had this moment and then going up, but from the left of -4 and from the right of -4, if I zoom in from the left and the right of -4, so if I go up to my function here, I'm on the left side. Right, this would be to the left. It's approaching this moment, this point. Well, that point would be -4, 1. And it's doing the same thing from the right. On the right side, right, on the right side of that -4, if I go up to my function, it's coming down here and it's also approaching that moment. So from the left and the right of -4, both sides approach the point -4, 1. 1 is the y value, or the function value. So both sides are approaching 1. All right, so 1 is the answer to this. The limit as x approaches -4 of my function is equal to 1. Both sides approach 1. All right, -3 is the next one we're going to look at. So as x approaches -3 on both sides, what's the function doing? F of x is approaching what on both sides? Who's -3, right? -3. Yeah, -3. All right, so -3 puts me, so again, I'm going to erase this so that I don't have as much stuff to look at here. All right, so -3 puts me here. There's my -3, and so I go up to my function. And so the left of -3, the right of -3, looks like it's approaching that moment. All right, and to me, it's pretty close to 4, so I'm going to say it's approaching the point -3, 4. And so from both sides, it's approaching 4. So 4. All right. As x approached 9 on both sides, what is the function value approaching on both sides? So again, on both sides. Oops, sorry guys. All right, so positive 9, no longer the negatives, positive 9. All right, so I'm over here at positive 9. All right. from the left of positive 9 and the right of positive 9 is approaching. Now, it does not exist at negative 9. F of x is undefined at, not, I said negative 9, at positive 9. But that doesn't mean the limit doesn't exist. In this case, the function didn't exist, but the limit does, because the limit doesn't care what's happening at 9, just what's happening to the left of 9 and the right of 9. And so on both sides of 9, it's approaching this open point. It is an open point. It's the open point 9, 2. Right, it's approaching it. And so 2 is the answer, right? From the left of 9, it's approaching 2. From the right of 9, it's approaching 2. It never gets to 2, doesn't exist at 2, but the limit does. The function doesn't, but the limit does. And so the limit as x approaches 9 on both sides is 2. So the limit of 9, limit as x approaches 9 from the left and the right is 2. All right, now 3, the first one here, it's hard to see, but there is a negative, so I am looking to the left of 3. So as x approaches 3 from the left, what's the function approaching? All right, so 3 from the left. So I'm going to go to 3. So 3 is here. Right, there's my 3. First to the left. So, right, the left would be on this side. So I'm going to go up here. This is on the left. Right, this is to the left of 3. On the left of 3, my function's approaching this moment. That moment is 3, 4. Now, it doesn't exist there. It's an open point. So the function actually never gets to 4. But 4 is the wall of that piece of the function. The function approaches as close as it possibly can to 4. So it gets to 3.9, 3.9999, 3.999999999, infinitely many 9s after 3. And so 4 is the limit. It's the wall. And so from the left only, the left of 3, my function approaches 4. So the answer is 4 to that one. All right, now 3 in general. As x approaches 3 on both sides. Well, we already know as x approaches 3 from the left, y approached 4. Well, what's happening to the right side? Mind if you remember the picture, the right side's going to approach something different. There's a jump. Whenever there's a jump, this is going to not exist. All right, if I go back up here and look at my function, so the left, it was up here at 3, 4, but if I'm to the right, right, the right puts me on this piece of my function on the right side of 3, it's approaching that 3, 2. Right, the x value, as I'm approaching the x value 3, on the right side, my function's behavior is approaching the point 2, and it actually exists there. F of 3 would be 2, so it actually does reach 2, but again, the limit doesn't care that it did. All it cares is that it's approaching 2. And so from the right, it was approaching 2. From the left, it was approaching 2. Well, these are not the same. And so we say the limit does not exist because of that. Right? Left and right are approaching different values. All right, so that's a second example of finding limits graphically. We will stop the video there, and we'll pick up the last piece where we'll do a table example in the next piece.